What's up, everyone? Today we're going to talk about laws of logarithms, aka properties of logs. So let's get into it. So first, a refresher on properties of exponents because they might come in handy in a little bit. With this first example, when you multiply your bases, you add your exponents. So x to the second times x to the fourth would be x to the 2 plus 4, or x to the sixth. When you divide your bases, you subtract your exponents. So x to the 7 minus 3, or x to the fourth. So keep those in mind because they might come in handy in a little bit. They're very similar to what we're going to do today. So these are all the properties or the laws that we're going to go through today. We're going to go through each one separately, but before we do that, these are all in the formula booklet that IB gives you. So you don't have to worry about memorizing any of them. They are given to you in that formula booklet. And we're going to start with this first one, which is the product law of logarithms. So if you notice, similar to the product property of exponents we just talked about, when you multiply inside the logarithm and you want to expand it out, going this way is expanding, you add the two logarithms together. Or going the opposite way, if you have two logarithms that are added together and they have the same base, if you want to condense, you would multiply the two values you were taking the log of. So we're going to do both. First up, expanding. If I have the natural log, so it works for any types of logs, I have the natural log of 3 times x. So I'm emphasizing that, yes, it is just 3x, but it's also 3 times x. So if I want to expand that out, I'll have two natural logs, one of each piece of the product, so natural log of 3 and the natural log of x. And because they were multiplied together when I expand it out, they get added together. And that's it. Going the opposite way, condensing, we have two logs, common logs, that are being added together. As long as they have the same base, you can condense them together. So because these two logs are being added together, when I bring it to one single logarithm, I'll multiply the two values I was taking the log of. So 6 times y, or just 6y. And that's it for your product law of logarithms. Your quotient law of logarithms, very similar to your division property or your quotient property of exponents. When you divide two pieces inside of a log, when you expand it out, you subtract the two pieces. Alternatively, when you're given two logs that both have the same base and they're being subtracted, when you want to condense those two logs together, you will divide the two pieces you are taking the log of. So again, let's practice one of each. Expanding first, I have the common log of 7 divided by 3. Expanding means I'm pulling them apart. So that means I'll have two logs, one for the numerator, one for the denominator. Because they're being divided, these two logarithms that I have will be subtracted, or I'll put a subtraction sign between them. In example 4, I have the natural log of a minus the natural log of b, and I'm being asked to condense. Condense means you should have one single logarithm at the end. So I'll keep one natural log out front. Because I have a subtraction symbol between them, that means I'll have a divided by b. You want to keep it in the same order that they have it, so that means whatever's first goes to a numerator, whatever's last goes to the denominator. Right, so finally, our power law of logarithms, a little bit different. It doesn't connect easily to one of the exponent rules that we had talked about earlier. But if you notice, on the left-hand side of this equation, we have m in the exponent. And on the right-hand side of the equation, m is the coefficient. So in logarithms, they're unique that your exponent can move to the coefficient, or the coefficient can move to become the exponent. And it depends on which direction you're going in. When you're moving the exponent to the coefficient, so if I'm going this way, I'm expanding. Or if I move my coefficient to become the exponent, I'm condensing. All right, so let's do a couple. So for these first few, we'll remind you about what expanding and condensing means for the power law. Expanding meaning no exponents in your final answer. So that means I'm taking this exponent of 3 and I'm basically just dropping it off in front, or I'm moving it to be a coefficient. So the expanded version of this is 3 log of x. With or without parentheses around the x, it doesn't matter. In example 6, our final example, condensing means no coefficients of logs in the final answer. So since I have 5 times the natural log of y, I'll take that 5 and I'll move it to be the exponent of y. You'll see this 2 different ways, similar to how example 5 is written. I could have the natural log of y to the 5th, all y to the 5th in parentheses. You might also see it as the natural log of y and then the exponent of 5 on the outside. They're interchangeable. It doesn't matter which way you write it, but be aware that you'll see both, and they both mean the same thing.